All right, hi there. So this is a video for tangent ratios for right triangles. This is just going to go straight into finding tangent. So if you are not sure when I start how to find opposite, adjacent, hypotenuse, that sort of thing, I did start a video with sine and cosine. So this is sort of the third of the trio. So if you start to watch this and you're like, wait a second, go back and watch the other two first. All right, so tangent is usually the one we talk about last. I'm not really sure why, but we do. We usually do sine, cosine, and then tangent. I think it's maybe just because it's in this order. All right, so we already did sine, which is opposite over hypotenuse relationship. Cosine, which is adjacent over hypotenuse, and then tangent is going to be opposite over adjacent. And all these trig ratios are literally fractions, right, where you put the correct side over the correct side, and then when you mathematically compute those, you can find things like missing angles. All right, so tangent, we write it out like that as a tangent. When we go to write it in math, we just shorthand it to TAN. I usually give it a little whoop at the bottom. I didn't this time, just that way it doesn't look like a plus sign. But I will as I do this. I'm just using generic theta for now so I can talk about what tangent means, but when I do examples, I'll use the angle letters that I'm talking about. All right, tangent is my TOA. O is opposite. So I know the relationship for tangent is going to be opposite over adjacent. Now, my full assignment is going to ask you to find sine, cosine, and tangent for the same angle. If you were really doing this, like if you worked in a job where you needed to find an angle measure, you wouldn't use all three of them. You'd use one of them to find the angle measure, and then that would be enough. But because I want to make sure you can set up all three ratios, that's why that's what I'm testing. All right, so I'm going to go ahead and I'm going to draw a triangle. All right, I'm going to start with my general 3, 4, 5, and we are going to find the tangent of a couple of different angle measures. Okay, so I have angle ABC. It's going to be a 3, 4, 5 triangle again. Sorry, my marker is... I have a whole box of markers and they all are sort of crap, which is very annoying. All right, let's go ahead and let's find tangent of angle A. And then we'll go ahead and we'll find tangent of angle C. And what you're going to see is, even though I'm using different side relationships, I'm using opposite over adjacent, which we haven't used before, we're still going to follow the same steps for setting this up. So the first thing that I want to do is I want to find my hypotenuse. Even though I'm not going to use my hypotenuse in this ratio, I still want to identify it so I don't accidentally use it as opposite or adjacent. All right, since the easiest one to find is usually the hypotenuse, I always recommend you label it just to have it if you need it, but also to have it so it's out of the way if you don't need it. All right, so looking at this beautiful triangle, the hypotenuse, remember, is always the longest side or the side opposite 90. My longest side measure here is 5, so this is my hypotenuse. It's also opposite the 90-degree angle. So I'm going to label that my hypotenuse. Now, what that tells me is, whether I'm doing the tangent of A or the tangent of C, I am not going to use the number 5. All right, the number 5 will only show up if I'm using hypotenuse for my ratio. I'm using opposite and adjacent, so that 5 is not going to show up in any of my fractions for tangent. All right, now that I have the hypotenuse, I'm going to go ahead and I'm going to find my angle to identify my opposite and my adjacent. Okay, I usually identify opposite first because I think for most people it's the one that's easiest to visually find. Here is my angle. What side is all the way across the triangle from angle A? It's the one that's furthest away. They don't share anything in common. It's opposite. And that would be right here. So this is my opposite. Because I have hypotenuse and opposite labeled now, that means that the remaining side has to be my adjacent. Okay? So that's another reason why I like to label hypotenuse, because if you have it and you find your opposite, then if you struggle with adjacent, there it is. It's the only one left. All right, tangent is opposite over adjacent. So my opposite here is 4. My adjacent here is 3. So the tangent of A is 4 over 3. Now, if we go to C, C is obviously going to be related because it's in the same triangle. But now I still have my hypotenuse. This is still my hypotenuse. But now my opposite and my adjacent will have changed because what angle or what side is completely opposite this angle? It's now this 3. Therefore, the side next to, or the remaining side, 4, is my adjacent. So do you see how 3 can be both the opposite and the adjacent, and 4 can be both the opposite and the adjacent? It's completely dependent upon the angle that you're looking at. All right, so tangent C still is opposite over adjacent, but now my opposite is 3, my adjacent is 4. Okay, so tangent, opposite over adjacent, and the opposite and the adjacent, just like in sine and cosine, will change depending on which angle that you're looking at. All right, I'm going to erase this. I'm going to do another one just to give you a secondary example if you need it. Remember, if any of this you are struggling with or you have questions, make sure you come to my office hours. I have office hours Monday, Wednesday, and Friday. They are posted in my classroom. If those don't work for you, you can always just message me and we'll make an appointment that does work for you. Okay, now I'm just picking 3 random numbers. They are not necessarily going to create Pythagorean theorem and be perfect and beautiful, but that's just because I just want the setup of the ratios. If that infuriates you, then write an angry, strongly worded letter. All right, so let's see. I don't know, I'm going to say that this one is 15, and this one is 19, and this one is 23. Now, those won't actually work out if you were to square them and add them, but that's okay. That's not what we're worried about. We're worried about finding our ratios. All right. I keep wanting to do sine. I just really love sine, I guess. All right, let's find the tangent of A, and then let's go ahead and find the tangent of B. All right. Here is my angle A. Let's go ahead and identify our hypotenuse first. Our hypotenuse is always the longest side, and the side opposite the 90-degree angle. Longest side is here. Now, I don't need the hypotenuse for tangent. I need it for sine and for cosine, but it's out of the way now, and I'm not going to accidentally use it because I know hypotenuse is not included here. All right, the side opposite A is the side that is furthest from A. That's going to be this side 19. Therefore, the remaining side, which is right next to angle A, is my adjacent. Hypotenuse is not going to be included because we're going to use opposite and adjacent for tangent. Tangent is opposite over adjacent. My opposite is 19. My adjacent is 15. And what you'll see if you are a pattern person is, if you were to do this with a bunch of different triangles and you were looking for the tangent of one angle and then the tangent of the other, you'll notice that they're always reciprocals of each other because the opposite and the adjacent always switch. All right, now let's go to B. This is still my hypotenuse. However, now this is my opposite and this is my adjacent. Okay, so opposite over adjacent is going to be 15 over 19. Okay, like I said, where you would go from here is you would use this then to find angle measures. Once you have the angle measure, you could use that to find side measures if you're missing a side measure. All right, trig ratios and right triangles are really nice because they help you find missing pieces without very much work. All right, so if you have questions, make sure you contact me, make sure you come to my office hours, or make sure you message me, and we will get it figured out. And hopefully this will all go really well. And I'm sorry we're not in class together. I would much rather be there than doing this. But, you know, we have to do what we have to do. Bye, guys.